Good afternoon, everyone. Welcome. I'm Mark Janikis. This is Carlos, and he's going to be presenting some really cool stuff with .NET and Python, how to extend the Pro application. How many people have used Python add-ins before? Okay, I know you. We talked yesterday, yeah. And so this would be the only way to adjust or add things, provide value added as far as the application is concerned with Pro, right? There are no Python add-ins. There's no plans for the Python add-ins to move to Pro, so this is the way that you do it. Carlos had experience with C# when he got here, but when he did set out to do his first add-in, it only took him a couple hours to do a rows diagram, which was really neat. So it really, the act of doing it, once you have some familiarity with it, is actually pretty quick, and it's quite powerful. So I think you'll see that today. If you have questions afterwards, we're going to leave hopefully 5 minutes at the end with which to discuss said questions. And I'll bring this microphone around so everyone can hear your questions. So without further ado, Carlos Osorio-Murillo with his great presentation.
Thank you, Mark. Hi. Okay, the presentation today is extending ArcGIS Pro with .NET and Python. Okay, we are going to use a special case that is using density-based clustering, how we can improve that tool using an add-in. It's like the example tool. Okay, we know that the Pro is now it's a big application, and it's highly customizable in different ways. Like you can use C++, you can use Python, you can use .NET, but the front end of ArcGIS Pro is .NET. Like if we want to introduce new interactive properties in Pro, we have to use .NET as a base. Okay, we need to try to include in our workflows .NET, but when we want to process information, Python is the way that you want to go. Okay? The combination of both is going to improve your workflows. Okay, what is the objective of this presentation? Is integrate .NET with Python for improved workflows. We are going to use a density-based clustering tool for specifically one method that is called ArcGIS to improve that method using an add-in. I'm going to show you a quick demonstration how to create the add-in. It's a small video that is going to be integrated in the presentation. Okay. Why I'm going to talk about the clustering? Because clustering is a very important topic in machine learning, and for us in ArcGIS Pro, we are including many clustering tools that we can make. Okay. The last release, we created a new tool that is called Density-Based Clustering, in which we implemented dbScan, is one of the algorithms. The other one was ArcGIS, and the other one is dbScan. We are going to focus on ArcGIS because it's a very good algorithm that you can get more interactivity with the user. Okay, this is the tool. I'm not going to talk so much about this, but it's important to remember something about the tool. The tool results is a clustering, but also gave us information about an ordering and reachability distance. That information is going to be used for clustering and for detecting another clustering using different methodologies. Okay, that is the example of the information that we are going to use. Okay, what is optics? It's a very well-known algorithm for clustering, and okay, you can make automatic clustering or interactive clustering, and it's based on in this plot. You have here the order of each node or each point in your data set, and you are going to use this plot to generate those clusters that you see here. Okay, interactively we can select the clustering. In the case, it's kind of very useful if we can only change some parameters and see how the cluster change if we have this plot. Okay, what is the process that we have in ArcGIS? Sorry for this introduction, but we need to have a context for the adding. The first is we have a cloud of points, and using the density-based clustering tool, we're generating this reachability plot. And the system automatically detects the cluster using the reachability plot. You see, this is the same plot. One is represented using lines, and the other one is represented using points. But the good thing about using the scatter plot is that you can see the clusters and the center in the plot. Every time you see the valley in the reachability plot, is a cluster in the map. Okay, there is a good relationship between the plot and the reachability plot and the cluster. Okay, first, how we are going to starting the integration. We have the reachability plot, and we are going to create a Python toolbox. You know that the Python toolbox has many ways to create it, and it's very powerful. And internally in the Python toolbox, we are going to execute in this part is where we are going to extract information from the tool. You know, this is the Python stuff. I think that many of you have used the Python toolbox. It's implemented in ArcGIS desktop and also in prod. And I'm not going to go deep in the Python toolbox because it's something that probably you already know how to create it. What is the parameter that we're going to use? The feature data set, the minimum number of points, the tolerance, and the threshold. This is the tool that I created, and this is the execute that we are going to do. Imagine that you have your workflow, and this is the execute in Python. All the thing that I'm doing here is extracting information from reachability plot. You see here is the two fields that I mentioned before, the reachability order and reachability distance. The only thing that I'm doing is calculating and set the order. Okay. When we have the reachability plot, we can really extract information of all the clusters that we have below a threshold. Okay, we have a threshold here, and okay, if you reduce the threshold, we can have different clusters. When the different clusters, okay, this is the function that we can give you. This is a get DB scan. Remember that ArcGIS is an extension of the of DB scan. DB scan is using a specific distance to extract the cluster, and ArcGIS is using multiple distances to extract the cluster. And if we can move the distances, ArcGIS is able to extract the same cluster that make DB scan. This is one way, using a distance threshold. On the other way is using a tolerance. The tolerance is you have multiple clusters, and you want to merge the cluster according with the tolerance. In that case, you have here the Python code using a Python model that you already have in the ArcGIS Pro. In that case, you can use your own model, you can use whatever model. The idea is that you can have your own workflow in Python. Okay, how we can, what is the tool that we want to show you? This is a small demonstration of the tool. Every time when you change the slider, the system is going to be automatically updating both things. It's going to be updating the map, and it's going to update the table. The good thing about this is internally the Python code is estimating the cluster and also the colors inside of the map. It's a very simple. The input is going to be a layer. In the case, you need to have the layer already in the TOC. In the case, it's going to start the information. You have to set the minimum number of points, and you can change the minimum number of points, and you can play with that. It's the way that you want to find clusters inside your data set in iterative way. If you use only the Python tool, it's going to give you only one set of clusters. You say, OK, I have to run it again and again to see what is the best cluster. Because really, when you are working with clustering, you need to run multiple times to find what is the best option. With this add-in, you can have different options until you find the cluster that you want. OK, how to create the add-in? The add-in is really a very simple way. We have a URL that have all the indication how to create it using Visual Studio. Sorry, and the Visual Studio contains some ArcGIS utilities that you can use to create the add-ins. You have the ArcGIS Pro SDK for .NET. Remember that every time when you want to install the .NET, you have to check here the version that you are working with. In this case, the version 2.1. And the utilities. With these two tools inside your Visual Studio, you can create the add-in very fast and without any problem. Here is a small demonstration how to create the add-in. First, you are opening your project. You say, open project. I'm going to add the add-in. I'm going to put the name of my project. Okay, my project name is going to be add-in. The system automatically creates everything in the add-in, and you can change the properties of the project. Those properties are very simple to configure. Always the system is going to open this file config that. Then I'm going to add one control. The control that I'm going to add is a dock panel. You know, the dock panel is the one that gives me the property to use and insert more controls in the system, in the add-in. This I'm going to add the properties, and I'm going to change the name of the add-in. It's changing the name. It's a sample panel. Then I'm going to go and open the control view. The system is going to give me this empty space that is the dock panel. When I have the dock panel, the only thing I have to do is insert my different controls. Like I insert the combo box. In the combo box, it's going to get all the layers. Then I'm going to put the label to see, okay, it's going to be layers here. Then I'm going to put a new text box. Okay. Just the name of the text box. The second parameter that I'm going to introduce is the minimum number of points. Remember that in the Python tool that we created, we defined 4 parameters: feature class, minimum number of points, tolerance, and threshold. The important thing here is what is the slider. Slider is going to be the key point of this add-in. Why? Because every time when I change the slider is going to change and calculate the new cluster. This is the key part of this implementation for the add-in. Okay, I'm looking for where is located the slider. I'm going to start, create the slider. Remember each control that you have here contains some property that you can play. In that case, I put 10. Is the number of tolerance the maximum number of tolerance that I'm going to support. And in the vertical is going to be another one. It's creating the other slider. Is vertical because I want to give you the idea of you are changing is the threshold distance in the reachability plus. For that reason, I put that in vertical way. Okay. When you are designing creating the add-in, you put all this information, but internally you have one file that is the config .ml. That config is the information of all the big components that are inside of the add-in. Okay, for example, you have a button inside the ribbon in the ArcGIS Pro, and the information is going to be a, and it's going to be a method that is going to be called by the add-in. If you want to create a panel, the panel is going to be found in the config .ml. When you create the dock panel is going to contain an XML file in which you introduce each component and each object or each control of inside of the dock panel. And all the properties of the control is going to be in this file. Okay, how to handle the different events inside of the panel. First of all, we have the add-in. When we have the add-in, we get the layers. Okay, we need to create a method that say, okay, give me the layers that you have already in the app. Then when the system returns the methods, I can go and I can change the slider and the system has to update. But we are going to execute a tool, okay, we are executing a geoprocessing toolbox tool. And that geoprocessing toolbox is going to update the app. Automatically, after you update the app, the data, the system is going to update the symbology of that data and that you use in .NET. .NET is going to be for getting information in the app, in the TOC. Remember, the TOC is the information of all the layers that you have, and we are going to use that information to update the symbology. Okay, how is the method in C# that we are going to use to create to get the layers? First, we need to check which geometry is the one that we want to obtain. We want only the data set that contain points. Okay, we have here the feature class, and we say, okay, give me the feature class, the shape type has to be equal to point geometry. And okay, from all the shape files and all the feature class that you have in the TOC, the system is going to select only points. Then I have to select only the points data sets that contain one field. Remember the field that I told you that we are going to use the reachability plot? We need only the feature class that contains the field reach this, because it's the reachability distance. Okay? The system is going to ignore the other ones. Okay, this is the layer, and at the end, there is a property that you say update layers, and the system update the layers. Okay, now we are going to execute the Python tool that we already created. I put this Python tool as a hardcode reference path, but really you can integrate, you can create a resource inside of the project, and you can every time create a PYT. Remember, the PYT is only a test file, a Python file, and okay, you can have that file inside of your resources. Then, now I'm going to receive the arguments. For the minimum number of points, I get the information for min points. That is one property that is in the text box control. And for the threshold, I'm going to get the information for the value threshold. Remember the slider and both slider, we need to get information for both, and they execute the values. Here we are creating the parameters or the arguments of the toolbox that we already created. And here is the important part, how we execute the process. Geoprocessing execute tools async. That is the main function that you are going to use for execute the Python toolbox. You pass in the argument. If you want to test what is happening inside of your toolbox, you can add the information as a history. In that case, you can check if there is something bad in your Python script, you can check what is happening in your Python script. If you can remove that history in that case, because the system is going to create, every time when you move the slider, it's going to create a history. But I put that, it's only for example. But in theory, you only have to remove this parameter, but because you don't want to have increase the history of your project. Okay, this is now after you you execute the tool, you update the clusters inside the cluster inside of your data set. Now you have to change the symbology. The symbology in the case you need to get what is the symbol that you want to use. The symbol that you want to use is this circle shaped tree. How you know the name of the circle? Inside of the ArcGIS Pro, there is a database in MySQL, SQLite, sorry, that you can use to extract all the symbols inside the ArcGIS Pro. You can use one of the symbols and you can change your workflow. Then, when you have to define what kind of classification or symbology type you are going to apply in your data. In that case, you say, okay, I'm going to apply unique value. Why? Because inside of my data set, there is a column that is called color ID, and I'm going to plot the colors using this unique value. At the end, I'm going to apply in the layer the rendering scheme. Okay, this is remember that I create with 3 functions because the only 3 functions are inside of the add-in. We can have the information running. Okay, I'm going to show you a live demo of the add-in. The only thing that you require here is you can change the different cluster. It's changing the cluster, and for the treasure, you see that all the clusters started to decrease when I moved the treasure, reducing the treasure. Now the map is showing a small clusters. When I reduce the treasure and increase, oh, sorry. Sorry. Okay. Every time when you move the treasure, it started to show, you know, like a small line here is the treasure, and the system is detecting the different cluster in that below that treasure. Or you can merge different clusters. The good thing is that it's very interactive, but improves the power of the density-based cluster. Okay, this is my conclusions. The implementing add-in improved the geoprocessing tool. We have a density-based clustering tool, but with the add-in we improve because the interaction is going to help you to detect better cluster. It's a very easy way to really introduce a Python tool inside of the add-in. Really, if you want to use C# with Visual Studio to create an add-in, it's like you see the small video is some small steps, and you almost have the add-in running. Okay, if you need information or you need this project, you can go to this GitHub project, and all the information of GitHub project is going to give you on everything that I made here is already available. Okay, thank you.
Thanks, Carlos. We'll take questions now. Just really quick while I'm walking out, it looked like when you're doing the buttons, when you're doing the actual button part, that looks like BB. I mean, you're essentially when you're drawing or moving your widgets, it's actually writing the code while you're doing that, right?
Yeah, yeah.
So really, I mean, the code is very little for the actual buttons that you're creating. It's only when you're doing the actual interaction part where you're linking it to the Python code that it's going to call.
Yeah,
when you're calling the Symbology stuff, that's really the only code that needs to be written on the
.NET,
C# side.
because the process, the important part of this adding really is the Python code. The Python is the one that is doing the process. The slider is only how to introduce the information inside of the PYT. It's like a front end for your PYT. It's like improving your interactions, really.
Okay, questions?
What was the output of the Python Toolbox tool? Like, how did it not just keep adding new layers in your Pro project?
Okay, that is a good, very good question. In this moment, in the PYT, is altering the input data, is changing the input data, but you can have an output data, and the case system is going to add in the app the output, and you can change the symbology of that output. Really, the workflow is not going to change. It's going to be a little bit slower because every time it's going to add a new layer in the TOC, but everything depends on your workflow. If you want to have an output, of course you need to add the output in your TOC.
If you want a chart, if you're working with charts, the charts as of right now have to be slave to the data, right? So there has to be an attribute table, and so obviously does a map, right? Yeah, so essentially he's just using an update cursor to go through and change the integers associated with what group you're in, and then it resolves the chart in the rendering.
Hi, okay, so what I understood is you've got your Python toolbox with your functionality, your tool. Then you create a user interface in C and then add code to call your Python toolbox. But you also mentioned the config.daml. How does that fit in?
The config is when you created the add-in. It's internal configuration in the add-in. It's something that every add-in requires to really to create the ensemble of the C# DLL that is going to be used inside of in the app. But it's more the C# code that you had to learn. You don't have to write anything. You don't need the system. The extension of it is inside of inside of Visual Studio is going to edit the file for you.
So you don't have to edit or
modify. You don't have to. I show you because if you need to make something advanced, you need to start to play with that file because there are some applications that is only a doc panel, but if you want to change all the environment of Pro, you have to control all the buttons of Pro. In that case, you can create your own app behind of Pro.
Yes.
When you distribute the add-in, do you put the PYT toolbox inside of it?
That is a good question. For this example, I put external. I put the PYT external, but if you are going to distribute, you can put the PYT as a resource, a string. And the resource string is going to be a string that you can create the file on fly. And you execute that file when you execute the geoprocessing tool. It's like copying the string, write one file with that string in the temporal folder, and run your tool with that file. But you can contain the PYT inside of the project. That way you don't have to share both.
So when you have a brand new project, it looks like the two things that from Visual Studio you have to download two different extensions, right? And once you have those two extensions, you have a new project. A vast number of files gets laid down when you have a new project, right? And that skeleton gets you a lot of way there, right?
Yeah.
And then obviously the point and click part with the buttons gets you a lot of way there, right? That tells you functionally how the user is going to interact with it. And then you're just essentially looking to source the Python file in the right way and then render it in the right way.
Yeah, that is like you have to organize your Python code in the way that you can execute it very easily in the app, in the add-in.
So if they download, they go to that website that you have here, and they get your example.
They can go and they have this is the GitHub repo you have here, and you have an example of the add-in. In that case, you remember there is a line that you say, remember, according where you install your repo, you have to change the line because the PYT is referencing to that line. Okay, it's the only change that you have to do.
Yeah, so for newbies, you could just go get this one, bring it down, and then start experimenting by changing just a couple little things, right? Just by experimenting before you maybe start your own, right? But I think it's a good place to start. Thanks, Carlos.
Okay.
So I think that's it. We both appreciate you guys all coming out, and hope you guys have a great rest of your time.
Thank you.